Welcome back to the channel, guys. Hope you're doing extremely well, and this is your very own mascot of the site, and we are here with a lecture of the linked list, right? We had a long journey up till now. Okay, so the problem says we have to remove nth node from the end of the linked list. That is, you have been given a linked list such as this linked list 1 2 3 4 5, and you have been given n as 2. So if I start numbering the linked list from last, so it is my first node from the last, second node from the last, third node from the last, fourth node, and fifth node. N equals to 2 says I have to remove this node. And after removing this node, this linked list actually looks like 1, 2, 3 connected to 5. Okay. Now, how will I solve this problem? How will I solve this problem? So the first and the foremost approach, I can say that is the brute force approach. Brute force approach. What is the brute force approach? I say I have been given the linked list 1, connected to 2, connected to 3, connected to 4, connected to 5. Now up until now we have understood that if I have to remove this node, I will have to remove this connection and form this connection. That is, I will have a node, I will have to place a node here to carry out this deletion, right? Okay, so how will I proceed? I can easily say my first step will be to calculate length of linked list, right? Second, now, if I calculate the length of this linked list, what will be my length? It will be 5 in this case, right? And I have got my n as 2, And now, if you see, I have to place a node here at this position at 3. So, if I place my temp here, now I think all of you are actually familiar with the concept that I actually deal with the temp, right? To traverse, right? If I actually place a temp here, I will have to take one operation to go here. This is my first operation. Second operation to go here. Okay, second operation to go here. N equals to 2. 5 minus 2 is 3, and 3 minus 1 is 2. That is, I will have to take length minus n minus 1 uh, traversal, like one next, right? I will have to start my temp from here, and I will move it forward L minus n minus 1 number of time. I will reach here, and after I reach here, I will say third, the temps next is actually equals to temps next. Now, before you change this connection, you store the node in somewhere, right? X equals to temps next, and after you make this connection, you say delete x, that is free the memory of x, right? Okay, now this will actually convert the linked list for you. How will I proceed? The code for the same would be that I have got the linked list 1 2 3 4 5, and here it is null. Okay, so my code would look something like, I will make a temp which is equals to my head, now I will say my count, that is my length, is equals to 0. I will say while temp, I'll say count plus plus, and temp changes to temps next. Not this is not this is equals to, right? Okay, so how will this proceed? My temp is here, my count is 0, okay. I move into the loop and I will break this here. Okay, I will move into the loop, count plus plus, count changes to 1, temp goes to next. Okay, count changes to 2, temp goes to next, count changes to 3, temp goes to next, count changes to 4, temp goes to next, count changes to 5, temp goes to next, and as soon as temp goes to here, the loop breaks and I have my count as 5. So my length is getting calculated fine, right? I have my length as 5. Okay, now we calculated that I will have to do the operation length minus n minus 1, right? This is 5 minus 2 minus 1, that is 2 times. Okay, so I will say again, my temp is equals to my head, now for I equals to 0 up till L minus n minus 1 minus 1, okay, this number of times, what will I say? I will say temp goes to temp of next, right? You can see 2 times, that is temp is here, 1 traversal, 2 traversal, my temp actually comes here. Now the same operation, I will say x equals to temps next is equals to temps of next, and I will say delete x. So what will happening? I say I will assign it as x, I will break this connection and form it here, and I will say delete x. Okay, this doesn't exist, and I've actually got my linked list. I've actually got my linked list. Now there is an edge case here. What is the edge case? Suppose I say my n is equals to my length. My n is equals to my length. So I'm saying that here length is 5. So I want to remove the fifth node from n, right? So this is my first node. If I mark it, this is my first node from n. Second node, third node, fourth node, fifth node. Okay. So if I place my temp here and I move it L minus n minus 1, that is 5 minus 5 minus 1, right? That is minus 1, that is this. Okay, that is 0 till minus 2. That will, the loop will not move, and my temp is at head. My temp is at head. So if I will do the operation here only, I will break this connection, I will delete this node, and I will do something like this, right? This is not good. This is not good. I have to remove this node, but I am returning this node. So what is happening? After calculating the length, I will have to add a case condition that if my length is equals to my n, in that case we have to remove the head, we have to delete the head, and I will not tell you how to delete the head. It is pretty basic, and we have discussed in the second or third video in the playlist also. What do? We make our new head as this, and we delete our this head, right? With the, and this will be my new head. Only this operation you have to do, only this operation. So I guess you are okay with the brute force approach. This was a brute force. But why did I discuss brute force in such great detail? Because the optimized version also comes here. Now, before discussing the optimized, let us find the time complexity and space complexity. So as you can see, I used O of n operation to find the length, and O of n operation to traverse to the nth node from the end, right? So it is actually equals to O of 2n, that is O of 2 length of the linked list. But that is not good, right? It is efficiently O of n, and the space complexity is O of 1. But can I reduce this O of 2n to actual O of n? The interviewer might ask it. See, the question will get submitted with this also, right? This is also a very correct approach. There is nothing wrong in it. But it is always good to have two moves in the bag, right? Okay. So my optimized version comes right now. And this I have used recently, and I've learned recently, and I find it amazing. So suppose my linked list is 1, connected to 2, connected to 3, connected to 4, connected to 5, connected to 6, and this is connected to none. Okay. Now I have to remove second node from the end. My n is given to me 2. This is my first node, second node, third node, fourth node, fifth node, and sixth node, right? Now it is pretty evident I have to remove n equals to, this is the node that to be removed, right? And to remove this node, I want a pointer up here. I want a pointer up here, right? This is my head. Now think about it that this distance is actually 2. What is the distance of first and fourth? So it is 1, 2, 3, 4. This distance is actually 4. So I am saying that I have to traverse, I have to put my node n length minus n time position, right? Length minus n position. So you will say that you will have to calculate length first here also, right? You will have to calculate length here also. So I am saying no. I am saying no. I am saying that I usually, what when we traverse, when do we stop the traversal? My question is, when do we stop traversal? The answer to that is when, it can be first when I reach last node, when I reach last node, or second when I reach null, right? These are the two conditions when we stop traversal, right? There is no other condition I can do. So let me take the first option for you. I say I place one of my variables here. This will mark my ending. This will mark my end. Let us name it as n only, right? Now this distance is 2, 1, 2. I have to remove this node. This distance is 2. So I say, and I have to reach here. That is, if I'm standing at this node, I will have to take 1 and 2. That is 2 traversal. That is 2 n equals to 2 traversal. That is, if I place a pointer up here, that is 2 distance away. That is n distance away, to be precise. And name it as, let's say, temp. Okay, I name it as temp. Okay. Now, will this solve the condition? What I'm saying is, this end will actually mark end will actually mark end of traversal. End of traversal, right? And temp will give me required pointer. What I'm saying is, I place my temp here in the final position, I place my end here in the final position. This is a final value, this is the final value. My initial value will something look like this. I will move it back, that is end comes here, temp comes here, end comes here, temp comes here, end comes here, temp comes here. So my temp will be starting from head, my end will be starting from how many nodes further? How many nodes further? This will be 2 nodes further. Okay, so when, and 2, where is 2 coming from? This is coming from n, this is equals to n. So I am saying the approach will be, I place my temp at my head, I place my end at head. Now I traverse n times, that is while, like, no, it will be 4 I equals to 0 to n minus 1, n becomes n next, right? So this operation will place my temp here, will place my end here. Now I have to traverse it until my end is my last node, until my end is my last node, that is end comes here. And when end comes here, my temp will automatically come here. That is, I'll say while and last and next, while and next, that is, this condition is for the last node, right? I will say temp is equals to temp next and end is equals to end next. This will give me the operation, and at the last of this loop, my temp is actually reaching the 4th node and end is actually reaching the end node. Now the operation says I have to remove this node. That is very easy. If I have got temp in my hand, the same operations, I will say x is equals to temp next and temps next is equals to temp of next, and I will say delete x, right? That is clear to you, that is clear to you. So what is happening, let me try run it for you. Okay, so the dry run says temp equals to head, temp come here, end come here, right? Okay, for I equals to 0 to n minus 1, that is I will go for 0 and 1, that is 2 times. So end equals to end next, that is first operation end comes here, second operation end comes here. Okay, now while end next, is end having a next? Yes, move temp and next forward, temp end. Is end having a next? Yes, temp here, end here. Is end having a next? Yes, end here, temp here. Is end having a next? No, break out of the loop. I say x equals to temp next, that is I will assign this node to x. Temps next equals to temps next or next, that is break this connection, form it here, and delete x. This node is actually getting deleted along with this connection. That is, the linked list now becomes 1 with 2 with 3 with 4 with 6. My head remains the same position, and here, okay, my head remains the same position. Why I'm stressing the head remains the same operation? Because that is an edge case again. That is an edge case again. In the previous approach, we saw that head was an edge case. In the next operation, we saw head is the edge case. Why is head always the edge case? Because in the case of head, I actually have to define new head, right? This is the reason for this. So when will this edge case occur? Again, same, n is equals to L. 1, 2, 3, 4, 5. So in a 5 node linked list, I have to remove the 5th node. How will I handle it? Okay, so the approach will only tell me 1, 2, 3, 4, 5, 6. Length of linked list 6. N is equals to 6. I don't need this anymore, right? I have already devised the approach. I don't need this. What will happen? I will place my temp here. My temp is here. My end is here. N equals to 6. That is, E will move forward 6 number of times. So 1, 2, 3, 4, 5, 6. N becomes null. And becomes null with the help of this loop, and becomes null. So my condition says I will have to add a pointer here. I'm marking it as star. So the star line is if my end is equals to null. That means, what does that mean? It means that I have to remove head. So what will I do? I will say new head equals to temps next, and now delete your old head and return your new head. Return your new head. This is the only edge case you will have to handle, right? Okay. Now, this will work fine. And what is the time complexity now? So, if you see, we are actually traversing only one number of times. So, it is O of n, that is O of length of the linked list, right? So, it is actually the same, actually the same, but the interviewer might get impressed with this approach. Okay. So, please don't forget to tell him. Okay. Now, moving on with the next code section. Okay. Alright guys, so here we are in the coding area and let us try to complete the code really fast. So what do? We make a temp list node start temp which is equals to head and my end is equals to head. Right now I will say for int I going from 0 up till n I plus plus. What do? I make end equals to end next. Next thing I do, I will add a edge case, that is if end is equals to null. In that case, I will have to remove head. That is, it becomes list node star new head. What is a new head? It will be heads next. I will say delete your old head to free the memory and return your new head. Okay. Otherwise, if this is not the edge case, what is happening? We will have to move the temp and end. So while end last, that is end does not becomes the next last node. I will say temp equals to temp next and end equals to end next. Moving forward, I will say to remove the node which is the temp next. That is, I will say list node star x equals to temp next. I will make the connection temp next becomes temps next of next and I will say delete x and now return your head. This should work fine. Let us try to compile and run it. In the meantime, please do not forget to subscribe to my channel. I have almost completed the linked list lecture and I think this is the last lecture. Okay. And please drop a comment if you like the playlist and do check out the playlist if you have not checked it out till now. Okay, so it has been accepted. Thank you for watching and stay tuned for more such amazing content. I will surely bring out another playlist of another lectures also. Thank you. Have a nice day. Bye bye.